Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Go ahead, drop a comment below. Make sure you like the video and also share the video with somebody else. All right. Now, also want to give a shout out to Bethune-Cookman University down in Daytona Beach, Florida, founded by Mary McLeod Bethune. If you're not familiar with who Mary McLeod Bethune was and the work she did, please get familiar as soon as possible. All right. And also get more familiar with Bethune-Cookman University if you're not familiar with that institution and all the historically black colleges and universities. All right. Now, what we're getting into today is we're going to figure out some polynomial end behavior. Now, this is the polynomial x cubed plus 2x squared minus 2. And we're going to figure out the end behavior, meaning what's the graph going to look like at the ends of it, the ends of the graph, right? What's it going to look like at the end? Now, we're not going to graph the whole thing. We're not going to figure out what the complete graph looks like. We're just going to figure out what the end behavior looks like. That's one step in the process of graphing a polynomial, all right? And it's an integral part, right? Because we want to know what the end is going to look like. And then at another time, in another video, right, we'll figure out what the x-intercepts are and what it looks like in the middle. We're going to figure out all the different values and whatnot. But for now, we just want to know the end behavior. What do it look like at the ends? All right, now how do we figure that out? The way we figure that out is this. We read the function, f of x equals x cubed plus 2x squared minus 2, right? And then we say, okay, well, what's my lead coefficient? LC stands for lead coefficient, lead coefficient. My lead coefficient is the number that is adjacent to the variable with the biggest exponent. My biggest exponent is a 3, not the 2, the 3, x cubed, right? That's my biggest variable, x cubed, right? What's the coefficient? There ain't no coefficient written there, but what's understood don't need to be said. We know that when the coefficient is not written, it means that it is a positive 1. You have to know that. That's part of the language of mathematics. The coefficient is a positive 1. So let's write that right there. Just like if you only see a negative sign in front of a variable, that means that the coefficient is a negative 1. All right. That's part of math language. You got to know the language. All right. Now, what's the degree? The degree of this polynomial is 3 because that's the biggest exponent that we're dealing with. 2 is not the biggest. 3 is the biggest. So that means this is a third degree polynomial, right? Or cubic function, right? Third degree or cubic. Now, this is important because it tells us that this is an odd function, right? It's odd, or the degree is odd. All right. Lead coefficient is a positive 1. And that's 2 pieces of information that we need in order to tell what the end behavior is. Is your lead coefficient positive or negative? And is your degree odd or even? 2 main pieces of information. Is your degree odd or even? In this case, it's odd. Is your lead coefficient positive or negative? In this case, it's positive because it's positive 1. Now, what does that tell us? That tells us that our graph is going to look something like this. It's going to end up going up and to the right and down to the left. Down to the left, up to the right. So it might look like this. Something like that. All right? Something like that. Now, I don't know if it's going to cross the x-axis right here. I don't know if it's going to cross the x-axis right there. I don't know if it's going to cross the y-axis right there or the x-axis right here. I don't know that. But what I do know is that on the ends, it's going down to the left and up to the right. Down to the left and up to the right. Down to the left and up to the right. I know that for a fact because that's based on this information right here. So that's essentially what the graph is going to look like. But now what about this right here? What if I have to write this in this format? As x approaches infinity, what is f of x doing? As x approaches negative infinity, what is f of x doing? And listen, don't let this type of language or writing or these characters or this terminology intimidate you, right? All that is a variable. That's an arrow. That's the symbol for infinity, right? That means like the biggest number you can ever imagine. That's the symbol for negative infinity. That's just the smallest number you could ever imagine, right? F of x is just the value of y, really. F of x and y are synonymous, right? It means what's the value of the function when you put a certain x value into it. That's why the x is inside the parentheses. That's all that means. Don't let the terminology in algebra or pre-calculus intimidate you, because that's where like a lot of people get caught up. They get so intimidated, like just looking at the language of math, and they never actually learn it, and they don't take the time to just sit and just think and just listen and try to figure it out because they too intimidated, they too shook, right? So don't get shook by that. All right. So anyway, as x approaches infinity, what does that mean? That means if I'm on this graph, right, and I'm going toward positive infinity. Positive infinity is that way on this graph. It's this way, right? Because that's where the positive number's at, right? Because remember I said infinity is the biggest number you could ever imagine, right? So what's happening to the f of x or the y's? F of x and y are the same thing. F of x and y are the same thing. What's happening to the y's? It's going up. It's up, right? It's going up, right? Like the roller coaster when it's going up before it hit the drop, right? It's going up. So that means that the y's are going toward infinity also. So that means we would say as x approaches infinity, f of x also approaches infinity. All right, little sideways 8 to show infinity. Now, what about when x is approaching negative infinity? That means when x is going to the left, right? Like this, right? Your x values are going that way. They're going that way. They're going that way. They're going that way, right? The x values are going that way. What's going to happen to f of x? F of x is going to be going down, 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 right? What's down there? Negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. So they match up like that. All right. So this is just a couple of ways to express this, right? And this is how we find the end behavior of a function. All right. So go get some practice with these. Remember, look for your lead coefficient, look for your degree, and then you know what to do. All right. Shout out to Mary McLeod Bethune and Bethune Cookman University. I'll see you all on the next video.